All right, here we are with section 7.4, and our essential question is, what are the properties of the diagonals of rectangles, rhombuses, and squares? So remember, a diagonal, let me just draw a real quick picture here, connects the opposite corners. So this line cutting it this direction would be considered a diagonal. So let's look at our learning targets. Our first one is to use properties of special parallelograms. Our second one, we're going to use properties of diagonals of special parallelograms. And then our third learning target is to use the coordinate geometry, so using our coordinate plane to identify special types of parallelograms. So let's look at this core concept first. So these are some major parallelograms that we're going to be dealing with. A rhombus, a rectangle, and a square. So a rhombus is a parallelogram with four congruent sides, right? And we remember about a parallelogram is that both opposite sides, pairs of opposite sides, are parallel. So we know that as well. So these two sides are parallel, and these two sides would then also be parallel. But we also know with a rhombus they are the same size. So a rectangle is my parallelogram with four right angles. And then a square is a parallelogram with four congruent sides and four right angles. So a square combines kind of these two things. So we'll just keep going on. So here are some corollaries. And remember, a corollary is something that we've already looked at. We've already looked at the proofs, and so this is just another point of it. So this first one, a rhombus corollary. So a quadrilateral is a rhombus if and only if it has four congruent sides. So that's just one of those rules that we know about a rhombus, that it has four equal sides. So then 7.3 is a rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles. Well, we already knew that about rectangles. And so then our fourth one for 7.4 is our square corollary. So a quadrilateral is a square if and only it is a rhombus and a rectangle, meaning all of its sides are the same and all of its angles are 90 degrees. So we can just keep those in mind as we go along. So here we go. For any rhombus QRST, decide whether the statement is always or sometimes true. Draw a diagram and explain your thinking. So let's look at part A. So I know I'm going to just draw it out, and it does not have to be perfect, clearly. And I know that it's a rhombus, so I know that all the sides are the same. And I know that it is QRST. And when I'm labeling a quadrilateral, I always kind of go in a circle. As I touch the points, that's the next one that's named. So I know that it's going to be QRST. It doesn't matter where I start as long as I continue in a line around it. So here I'm looking at angle Q and angle S. So I'm looking right here, and I'm looking right here. So here's my drawing, right? And I know that based on the parallelogram opposite angles theorem, that this is always going to be true. One thing I know about a rhombus is that it is a parallelogram, and so that I do know that opposite angles are true. So this one's always true. So now let's look at part B. It's asking me about Q and R. So again, I can draw this, right? And I pushed the wrong button. So a rhombus, if rhombus QRST is a square, then all my angles are congruent, right angles. So Q would be congruent to R if QRST is a square. But I know that not all rhombuses are squares. My rhombus could be something like up here, so I know it's not always true, but it is sometimes true. So there's my two differences. The opposite angles will always, no matter what kind of a shape it is, be the same, but consecutive angles will only be congruent if we're talking about a square or rectangle. Okay, so here's example number 2. We're asked to classify the special quadrilateral and then explain our reasoning. Well, so I see here it's drawn out, and I see that all four sides are the same, so I know that it's a rhombus. But it could be a square, right? Because it's a specific square if all my angles are 90 degrees. Well, I see here that this one is not 90 degrees, so I know for sure that it's not going to be a square. So let's just see what they said in the book. So again, like we said, it has four congruent sides. So I know that it is a rhombus. And then I'm also told that one of the angles is not 90 degrees. So then I know it's definitely going to be a rhombus and not a square. So here are some monitoring progress. Try them, see how you do. So here are some more theorems. Okay, so now we're looking at our second learning target, which was dealing with the diagonals, the things that are going from opposite corners. So our first theorem is the rhombus diagonals theorem. So a parallelogram is a rhombus, right? If and only if its diagonals are perpendicular, right? And perpendicular means 90 degrees. So that's denoted by this little box, right? And I know that this is a parallelogram as denoted by the arrows, and I know that it's going to be a rhombus if this is 90 degrees. So my second theorem is my rhombus opposite angles theorem. So a parallelogram is a rhombus if and only if each diagonal bisects a pair of angles. And remember that bisect means cut in half. So if my angles are cut in half, then I know that it is a rhombus. So let's look at this as an example. So here is example number 3 in your book. So let's look at this. Find the measures of the numbered angles in rhombus ABCD. So again, if I didn't have a picture, I would go ahead and draw my picture to start with, and I see that I'm given one angle. So I want to use the rhombus diagonals theorem and my opposite angles theorem to find my measurements. So I know that my diagonals of a rhombus are perpendicular, and I'm told that this is a rhombus, so I can go ahead and use these. So I know that the measure of angle 1 is going to be 90 degrees because I know that my diagonals are perpendicular. So let's look at angle number 2. So I know that this one is also going to be 61 degrees. This is my alternate interior angles. Remember, we learned about this when we were talking about parallel lines and cut by a transversal, right? How this angle is congruent to this angle. They're alternate interior angles. Same sort of thing here. We've got our parallel lines and we've got our transversal. So we can use that information that we've already learned as well. So the measure of angle 3. So I know that 3 is also going to be 61 degrees because my opposite angles theorem, my rhombus opposite angles theorem, tells me that my angles are bisected, are cut in half. So if this half is 61 degrees, I also know that this half is 61 degrees. So then I can find angle number 4 because this right here makes a triangle. And if I know angle 1 and I know angle 3, I can add those up and get to angle 4. So I know that the sum of my angles in a triangle, right, is my triangle sum theorem equals 180. So I plug in the 2 that I know and I can find the measure of angle 4. So I just subtract these. So I know that angle 4 is 29 degrees. So there's my final solution. So here are some more learning, monitoring progress. Try them and see how you do. So here is another theorem, right? We've been dealing with rhombuses and now we're going to be dealing with this rectangle. So my rectangle diagonals theorem. So a parallelogram is a rectangle if and only if the diagonals are congruent. And congruent means the same length, right? So if I know AC is congruent to BD, then I've got a rectangle. Okay, so let's look at this example. And this is example number 4. This is example 4 in your book. So let's look here. You are building a frame for a window. The window will be installed in the opening shown in the diagram. The opening, let's look at part A. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? And then explain. So the first thing I see is that my opposite sides are the same length. So that would lead me to think, yes, it's a rectangle. However, I don't know anything about the angle measurements, so I can't assume that this is a rectangle because I know nothing about these angles. So I can just say that, no, I know that it's going to be a parallelogram because my opposite sides are the same length, but I cannot guarantee that it's a rectangle. So let's look at part B. So I measure the diagonals of the opening. So my diagonals are 54.8 inches and 55.3 inches. What can you conclude about the shape of the opening? Well, based on my last theorem, I know that if this was a rectangle, my diagonals would be the same. And you can see that they're not. So I just can say that this is not a rectangle because the diagonals are not the same. So here we go. Here's example number 5. So in rectangle QRST, QS equals 5x minus 31 and RT equals 2x plus 11. Find the lengths of the diagonals. First thing I note is that I'm told that this is a rectangle, right? I don't have to guess based on its shape because I never want to do that anyways. So I know that my diagonals are going to be congruent. So I know that QS is going to be congruent to RT, right? Because those are my two diagonals. Well, if I know that QS has a measure of 5x minus 31 and RT has a measure of 2x plus 11, I can set both of those equal to each other, and then I can solve for my x value. And I always use my picture just to double check that I got the whole thing, because I know that it's QS and RT. Oftentimes they'll give you pieces of your diagonals and then you have to find the rest of it. But here they gave us the entire length of the diagonal, so I can go ahead and set them up. So I'm going to subtract 2x from both sides, which leaves me with 3x minus 31 equals 11. Then I add 31 to both sides, so which leaves me with 3x equals 42. Then I'm going to divide by 3. Divide by 3. X equals 3 goes into 4 one time. There's 1 left over. 3 goes into 12 4 times. So there's x equals 14. So I'm not quite done because I'm told to find the lengths of the diagonals. I was not told just to find x. So now I take what I found for x and I plug it into one of my two equations up here. I'm going to pick my 2x plus 11, but it really doesn't matter because they're the same thing. So I plug in what I got, which was 14, and I know that 2 times 14 is 28 plus 11, so I end up with 39. So here is the final length of my diagonals. I can't stop here when I found x. I have to plug that back in to find my whole value here. So here are some more monitoring progress. See what you can do with them. So now here we're looking at our final learning target using coordinate plane, using our coordinate geometry. So here we go. This is example number 6 in your book. So decide whether this quadrilateral, right, ABCD, with vertices A at -2, 6, B at 6, 8, C at 4, 0, and D at -4, -2 is a rectangle, a rhombus, or a square. Give all names that apply. So let's walk through the steps that we did. So I know the vertices. So first I have to figure out what kind of parallelogram it is. First thing I would always do is to draw it out so we have a visual and something we can work with. So now it looks, just based on looks, it looks like my sides are congruent and there's no right angles. So now I can check the lengths and the slopes, right, of all of my sides. So if my diagonals are congruent, then I know it's a rectangle. If the diagonals are perpendicular, then I know it's a rhombus. If they're congruent and perpendicular, then it's a rectangle, a rhombus, and a square. So, right, I am dealing with, let me go ahead and draw them. This is going to be a diagonal, right, from opposite points, and here's my other diagonal. So I'm going to be dealing with those. So I want to use my distance formula to find the lengths of my diagonals, right? So the distance from A to C, I use my distance formula, which would end up being 6 times the square root of 2. To find the length from B to D, again, I use my distance formula, which ends up being 10 times the square root of 2. So you'll even see here, before we simplify, I have the square root of 72 and the square root of 200. So I know for sure that they're not congruent because they're not the same length. So I know that it is not a rectangle. Then I also know that it cannot be square, right? Because if it's not a rectangle, it's not a square. So now let's see if it is in fact a rhombus. And I know that it would be a rhombus if these two were perpendicular. So I'm going to look at the slope between these two. Okay, so I can find the slope of AC. So I do my rise over run. So to get from point C to point A, and I know it's going to be a negative slope, right? And I go down 1. I'm sorry, everything's in 2. So I go down 2, 4, 6, and I go over 2, 4, 6. So my slope ends up being a down 6 over 6 and -1. So now let's look at the slope of BD. So I go up 2, 4, 6, 8, 10, and I go over 2, 4, 6, 8, 10. So I have 10 over 10, which equals a positive 1. So remember, using our slopes of perpendicular lines, if I have a negative reciprocal, that means that my lines are perpendicular. And here I can go ahead and multiply them and get -1, or use my negative reciprocals, and I see that they are in fact perpendicular. So I can classify this quadrilateral as a rhombus. So if I really want to go further, I can check the side lengths, right? Find the distance of all of my side lengths, and I would find that each of them had the same length, so then I know that it is a rhombus. I can also check the slopes of 2 of my consecutive sides, right? And to see where the slopes line up. So I know that they are not perpendicular, right? Because my slopes are not the negative reciprocals of each other. So it cannot possibly be a rectangle or square, but I do know that it is a rhombus because the diagonals are perpendicular. So here is your last monitoring progress. Try this before you move on to the homework. So let's look at our learning targets. that we checked out. So our first one is use properties of special parallelograms. So these are our special parallelograms, rhombus and rectangle and square. And those properties that we're talking about are if the side lengths are the same or if the angles are the same. And we know that if the sides are the same, it's a rhombus. If the angles are the same, it's a rectangle. And if both of those things are true, then it's a square. So our second learning target was use properties of diagonals of special parallelograms. That's when we used, we found that the diagonals of rhombuses were perpendicular and the diagonals of rectangles were congruent, were the same length. So we can use that information to help us determine some information about our quadrilaterals. And then our third learning target was use coordinate geometry to identify special types of parallelograms. You're going to be doing this pretty often. You're going to be given some points of a quadrilateral, and then you have to figure out, well, is it a rhombus? Is it a square? Is it a rectangle? And how do you know? Be sure to look back at the properties that we've looked at to actually explain how you know these things, because that's what we're really looking for. So now I want you to go ahead and start working on that homework for this section.